Hello. So this is the second part of section 4 of chapter 10. We have studied measures of central tendency. So you learned how to find mean, median, and mode, right? And then we move to variation. To find the variation, the first thing that we used was finding range. So range was what? Maximum minus minimum. Yeah, the difference between maximum and minimum. And then we learned interquartile range. To find the interquartile range, first we found the median. Median is Q2, the 50th percentile. Then you found Q1, which is 25th percentile, and Q3, which is 75th percentile. IQR, interquartile range, can be found as the difference between Q3 and Q1. So Q3 minus Q1 is interquartile range, right? And we use the box plot. Another name for box plots is a box and whisker plot. To find the box plot, you need to find 5 number summary. 5 number summary is the minimum, first quartile, median, third quartile, and maximum, right? Then we also have learned how to find the outliers. So if you don't remember, please look at the notes for the previous lesson and watch the video, okay? Today we're gonna do a little bit more math here. It's not a hard concept. There are just more formulas for you to remember and use to calculate, okay? So we're gonna talk about the variation. The first one is mean absolute deviation. Mean absolute deviation. So as the name is indicating, we're gonna find the mean, and we're gonna find the absolute value of the difference. Deviation means difference. So you're gonna find the absolute value of the difference between actual value and the mean. Okay? So to find mean absolute deviation, the first thing that you have to do is you need to find the mean. Okay? So we know how to find the mean. For example, if you are given these test scores here, 99, 67, 84, 99, and 67, you know how to find the mean. Mean can be found by finding the sum first. So add them all together and divide it by the number of items. So you have 1, 2, 3, 4, 5 divided by 5, and you get 83.2. That is the mean. Mean of the sample, we put X bar there, right? So that is the mean of these samples. Then what you need to find is you're gonna find the absolute value of each difference between actual score and the mean. Okay, so here in the second step, what you're gonna do is you're gonna find the difference between test score and the mean. So 99 minus 83.2 and find the absolute value, which is 15.8. That means the order doesn't matter here. You just find the difference between 99 and 83.2. Because it's absolute value, you always get positive numbers, okay? A second one, 67 minus 83.2, and absolute value for that is 16.2. Continue to do that, and then you're gonna find all of these values, right? Then you're gonna add them together, that's the sum. But it's mean absolute deviation. So you're gonna find absolute value deviations mean, which means this is a sum. So you're gonna divide that by the number of items. So divide that by 5 and you get 12.96. Okay, that is called mean absolute deviation. Right, so write this down on your notebook. Mean absolute deviation can be found. First, you're gonna find the mean, right? You're gonna find the mean because you have to find the difference between mean and the score. So you need to do subtraction of score and mean, right? But you need to find the absolute value of that. Again, think about the meaning of this. You're gonna find the mean of absolute differences, okay, absolute value of the differences. between actual score and the mean. So you're gonna find the absolute value of actual score and the mean, and you're gonna find the mean of that. So you need to add all of these absolute value of the difference between score and mean, then divided by n. So that is the average distance each data point is away from the mean, 12.96. Okay. Again, remember, this is for the variation. We need to, this is good indication of how far away our data is from the mean or from the average. The second variation that we're gonna learn here today is variance and standard deviation. I put these two together because they are closely related. Variance is square of standard deviation, or in inverse, you can think about if you find the variance, you can find the square root of that as standard deviation. Okay, so the steps to find the variance is you're gonna find the mean, right? After you find the mean, it's very similar to the mean absolute deviation that we just talked about. Mean absolute deviation. To find that, you had to find mean first, right? Same for variance. Because we're talking about the average, we have to find the mean. Find the mean first, then find the difference. Instead of doing absolute value of that, we're gonna square that. So you're gonna still have positive numbers there. That's very similar, right? But this time we're gonna put square there. Then add them all together. Add them all together. So very similar, right? Similar steps. You're gonna find the sum of the difference of actual value and the mean squared. Then you're gonna divide that by n. So you're gonna find the mean of the difference between actual value and the mean squared, whole thing squared, right? After doing that, you're gonna put a square root to find the standard deviation. So far up to here, that is the variance. If you put a square root of that, that becomes the standard deviation. I put that here by extending, this notation of sigma. Sigma means sum of. That means sum. So that means each of this variable, the value minus the absolute value squared. So x1, the first value minus mean, square that, and second value minus the mean, square that, and so on and so on. Add them all together, then divide it by how many we have. This part inside of the square root is the variance. Okay, if you want to find the standard deviation, you can just put square root of that. So here I'm giving you some scores. We have some scores like 180, 70, 50, 50, and 10. That's what we have collected. Suppose that. And then I would ask you to find the variance and standard deviation. In order to do that, you need to find the mean first. So what is the mean for these data? The total, the sum is 360, and we have 6 values. So 360 divided by 6 is 60. So we know the mean is 60. Then you need to subtract the mean from each number. So 100 minus 60, 80 minus 60, you're gonna put them here. Okay, so here 100 minus the mean, 100 minus 60, 80 minus 60, 70 minus 60, 50 minus 60, 50 minus 60, 10 minus 60. So some of these values are negative and some are positive, like these. 50 minus 60 is negative 10. But it doesn't matter because we're gonna square them. Okay, so we're gonna put them square So the first one was 40. I will just actually give you the value here. 40 squared is 1600, and 80 minus 60 is 20. Square that, you get 400. 70 minus 60, you get 10. Square that, 100. 50 minus 60, negative 10. Square that, 100. Same thing, 100. 10 minus 60, negative 50. Square that, 2500. Then what do? You add them together. So you get 4800. Then what do? Divide it by 6. So you get 800. That is the variance. How do you find the standard deviation? Just put square root over variance. Then that is your standard deviation. Oh, you can do this step with your calculator. Okay, so that's the step. So write this step down. Then you can easily find variance and standard deviation. Okay, so let's look at a little bit more. I want you to take some time by pausing this video and solve this all by yourself. Okay, so I'm pretty sure you have solved this problem, right? It takes some time, but it's not actually very hard, right? Okay, so let's do this together. Okay, so Professor Abel gave 2 group exams. Exam A had grades of 0, 0, 0. Oh, that's really bad. 100, 100, 100. And exam B had grades of 50, 50, 50, 50, 50. And you need to find the following values of each of this exam. It's really fun, I think. So let's find the mean. Okay, so let's find the mean of exam A and exam B. So I will just put A and B here. How do you find the mean? You find the sum and divide it by the number of items, right? So we have 0 plus 0 plus 0 plus 100 plus 100 plus 100, which is 300. Divided by, we have 6 exams, so divided by 6 is 50. So mean is 50. How about in exam B? For exam B, it's 50 plus 1, 2, 3, 4, 5, 6. 6 of them, so 50 times 6, which is 300 again. And you have 6 items, so mean is 50. So central tendency using mean, we know it's exactly the same. But as you can see, it doesn't look very same, right? So even if the central tendency is very similar, but we know that the variance should be different, because for exam A, between 0 and 100, the gap is too big, very big, but between 50, 50, 50, they're all same. So there's not real variance there, right? That's why we are doing this activity here. So let's take a look at part B. What is the range? In A, what is the maximum? 100. What's the minimum? 0. So the range is 100. It's really big, isn't it? How about for exam B? Maximum is 50 and minimum is also 50. So there's no range. Range is 0, right? Now let's look at part C. Mean absolute deviation. We abbreviate that with MAD, mean absolute deviation. So to find the mean absolute deviation, you can do, let's do A first. You can do absolute value of the difference between the mean and actual values. So we can do 0 minus mean, 50, plus, what's the second one? 0 minus 50. Third value is also 0. 0 minus 50. And the fourth value is 100, 100, 100. So we can do the same thing here 3 times. 50 plus 100. This is the absolute value. 100 minus 50 plus 100 minus 50. Then you can divide this whole thing by number of items, because it's mean of absolute value, of absolute deviation. So divided by 6. What is this? 50, 50, 50, 50, 50, 50. All of these values are 50 and you have 6 of them. So 6 times 50 divided by 6, you get 50. So MAD is 50 for exam A. How about exam B? We can do the same procedure here. So you're going to find the absolute value of the difference between mean and actual value. All of these values are 50 and our mean is 50 and you have 6 of them and divided by 6. I didn't even have to do all that, right? So I can erase it. But that is equal to, you can divide 6 and 6. Absolute value of 50 minus 50. What's 50 minus 50? That's 0. 0 over 1, which is just 0. So we can see that in exam B, there is no mean absolute deviation. Just like the range, it's 0. And mean absolute deviation is also 0, which means it's not varying, right? Okay, how about part D? You're gonna find standard deviation. To find the standard deviation, it's a little bit lengthy. I mean, it's not hard again, but just procedure-wise, it's a little bit longer. So I will show you here. We are doing part D, standard deviation. To find the standard deviation, you need to find the variance first, right? So how do we find the variance? Okay, so let's put standard deviation first. Okay, for A, I will just say A and B. Standard deviation, to find the standard deviation, as I said, you need to find variance first. Then you can put square root of that, right? So I can say square root of deviation. So square root of deviation. How do you find the deviation? You can find the difference between actual value and the mean, then you square that instead of find the absolute value, right? So we're gonna do 0 minus mean, which is 50 squared. How many do you have? You have 3 of them, so I can put 3 times that, and we have 100 minus 50. You can square that, and how many do I have? I have 3 of them, so you can multiply that by 3. Then you can divide that by number of items. I have 6 of them. So inside of the square root, that's the deviation. To find standard deviation, you can just do absolute value of that, right? So what's inside the square root? We can have 3 times 0 minus 50 is negative 50. Negative 50 times negative 50 is positive 2,500, right? And same here, 3 times 100 minus 50 is also 50. 50 squared is 2,500 over 6. Then you can see that, oh, this is actually 6 times 2,500. I'm writing this way because I can cancel 6 out. If you want to distribute 3 times 2,500, you can do that. You get 7,500 inside, and you have another 7,500. So you can add them first, then divide it by 6, then you're gonna get 2,500. It's the same result. Anyways, so if you do that, square root of 2,500 is 50. You can use your calculator, or you can just think that, oh, 50 times 50 is 2,500. So the standard deviation for exam A is 50. How about for exam D? We can do the same procedure. So for exam D, I need more space, so I will put it here. standard deviation of, let me put B here, exam B is square root of, find the deviation first, right? So find the difference between the value and the mean. We know that each of this value is 50 and the mean is 50. So you square that, but how many do I have? Exactly same value, 6 of them. So that's what we're gonna get and divide it by 6. So we can cancel this out, but luckily this is 0. I said luckily because it's easy calculation. 0 squared is 0. So in the square root you have 0 over 1, which is 0. Square root of 0 is just 0. So I see that for part B here, exam B, we have zero standard deviation, which means every value is the same. There's no difference between the values. Okay? All right. How about E, median? How do you find the median? To find the median, what you need to do is you need to put the values either ascending order or descending order. It is already written as ascending order, right? And you have 6 of the values, so you can find what is in the middle. Between 0 and 100, the value between 0 and 100, that's the median. So what's the mean of 0 and 100? That's 50. So 50 is the median for exam A. How about for exam B? Well, every value is the same, so we know mean of 50 and 50 is also 50. So yes, median is also 50 for both of them. How about interquartile range? To find the interquartile range, you need to find Q1, Q2, and Q3. Q2 we already found, right? So Q2, for this one, let me use different color. So Q2 is 50. How about Q1? Q1 is in between. Q2 is right here. So Q1 is what is the median of lower value. That's this one, 0. That's the Q1. How about Q3? Above Q2, you have 3 values and the median is this one, right? So we know Q1 is 0, Q3 is 100. So interquartile range, which is the difference between Q1 and Q3, is 100 for exam A. For exam B, we know Q1 is also 50, as Q2 is 50 and Q3 is also 50. So Q1, Q2, Q3 are all same as 50. Then what's inner quartile range? Q3 minus Q1, 50 minus 50, it's 0. So for this one, exam B, interquartile range is 0. For exam A, interquartile range is 100. So by looking at these values, we get to know that there's a big difference in the values for exam A, but for exam B, not much difference. Okay? So in this example, exam A has mean 50, mean absolute deviation of 50, and standard deviation of 50 as well. Exam A also has a median of 50 and interquartile range was 100. Reporting the 3 measures of spread together in each case demonstrates that the scores are widely spread away from the mean and median, right? In contrast with that, exam B has mean 50, mean absolute deviation 0, and standard deviation was also 0. Its median is 50 with interquartile range of 0. All of these descriptors for exam B shows, what does it show? It shows that there's very little spread of the data from the mean and the median. right? Yeah, this was chosen with extreme scores just to illustrate what can happen with measures of central tendency and measures of spread. So I think it was a good exercise. If you don't know how to calculate this, please remember the formulas and try to find each of mean, range, mean absolute deviation, standard deviation, median, interquartile range for this data again, or in the homework practice you're gonna have more problems to practice these too. Okay, try to remember the rules rather than just refer whenever you are solving the problem. Okay, all right, so now let's talk about normal distribution. So a distribution of data is a listing of all possible values of the data and how often they occur. So very important distribution is a normal distribution. A graph of a normal distribution is a bell-shaped curve, and we call that as a normal curve, like that. The normal distribution arises naturally in many real-world situations. That's why we are working on this. So for example, the students' height in the classroom, test scores, IQ scores, what else? Like SAT or ACT scores. Yeah, you can see that in a lot of examples, right? A normal curve is smooth and it's bell-shaped like that. That depicts frequency values distributed symmetrically. So you can see the symmetry here. There's a symmetry line, and this half and the other half looks very same, right? The normal curve is theoretical distribution that extends infinitely in both directions. That's why I put arrow on both sides. Okay, it gets closer and closer and closer to the x-axis, this side and the other side too, but it never reaches it. On a normal curve, about 68% of the values lie within one standard deviation. So when you're looking at this number 1, that means it's within one standard deviation. Because it's symmetrical, you can see that half of a 68% is 34%. So you have 34% and 34%. Together, 68% is within one standard deviation. Similarly, we can get to know about 95% lie within two standard deviation. So when we are adding all of these values together, that is 95%. Hey, what is half of 95%? Half, well, we don't even have to do half of it because we know this much is 68%, right? So I want you to do the calculation of 95 minus 68. Then you're going to find the difference between, 95 and 68. The difference shows this part and this part together, which will be 27%, right? And since these two are symmetrical, we can make that as a half. Then each one is 13.5% here and 13.5% here. Okay, but together we get to know two standard deviation is 95%. Okay, I want you to remember that. So again, within one standard deviation, there are about 68% of the value, and about 95% lie within two standard deviation. How about within three standard deviation? Within three standard deviation, all of these values together should be more than 95, right? The number is 99.7%. So 99.7% are within three standard deviation. Okay. This percentage represent approximations of the total percent of area, which is 100% under the curve. Okay. Okay. So here is one example for you. When a standard deviation, when a standardized test was scored, there was a mean of 500 and a standard deviation of 100. Suppose that 10,000 students took the test and their scores had a bell-shaped distribution, which means it's normal distribution, making it possible to use a normal curve to approximate this distribution. And what we're gonna do is solving these problems. Before I solve these problems for you, I want you to pause and consider this problem and ponder how to solve it. Okay, let's solve this problem. When a standardized test was scored, there was a mean of 500 and standard deviation is given to you. And the number of students is also given to you. And another important information that you want to use, it's a bell-shaped distribution. And it's asking, how many scored between 400 and 600? Hey, is that meaningful number? Probably it is. That's why it is given to us. So let's consider that. Why it is the important number. Okay. So we have mean of 500. The mean is 500. And standard deviation is 100. So when we have one standard deviation, we know in the bell-shaped data, it's symmetrical, and right in the middle is the mean, right? This is the mean, and we know this is one standard deviation, and it's symmetrical. So let's put one standard deviation, which means from mean, you can add one standard deviation and find the value there, and you can subtract one standard deviation and find the value there. So the mean is 500 and one standard deviation is 100. So if you add that, the value up here should be 500 plus 100, 600, right? And here it's one standard deviation less than the mean, so 500 minus 100, which is 400. So between 400 and 600 means it's within one standard deviation. So we know how many percent of the students are in this one standard deviation. We already know that number is 68%, right? And what else do we know? 68% of the people, total people, is how many scored between 400 and 600. So 68% of how many students in total? 10,000 students. How do we find it? 68% is 0.68 of multiplication times 10,000 is, you can just move 2 decimal points, right? So 6,800. Okay, that's how many students who has received within one standard deviation. Or this is the number of students who scored between 400 and 600. Then let's think about 300 and 700. We know two standard deviation is 200. So 200 less than 400 is 300. And 200 more than 500 is 700. So this is two standard deviation from all the way here to all the way there. Everybody here is within two standard deviation. Of course, the number increases, right? And what's the number? That is 95%. There we go. So 95% of 10,000 students. How do we find it? 0.95 times 10,000, which is 9,500. Okay. Now, the part C is how many scored between 200 and 800. We get to know 200 and 800 is 3 standard deviation, right? Because 3 standard deviation. Because 1 standard deviation is 100. 3 standard deviation is 3 times standard deviation. So 3 times 100, which is 300. More from here, which is 500 plus 300, 800, or 500 minus 300, which is 200. So this part, let me use different color for you. So this part from here all the way to there is the number of students who lie within 3 standard deviation. How do we find the standard deviation? How many scored within these two numbers? Oh, that's not the question. Hold on. Oh yeah, it is the question for part C. I was looking at D. Okay, for part C, how many scored between 200 and 800? We know the number is 99.7%. So here we have 99.7% of students, right? 99.7% of 10,000 students. In other words, the number is 9,970. Many students have scored between 200 and 800. We are including more and more students. Now, a little bit challenging question. So part D is asking you to find how many scored above 800. So we are looking at the students above, right here only, right here. It should be very little students, right? How do we find that? Well, we already know that number of students in this category, 3 standard deviation, is 9,970. Then if you take that much away from the total, we know that's the sum of this part, lower end and upper end. And since this is symmetrical, if you divide it by 2, you're gonna find only one part, because this part and that part has to be the same number, about the same number, right? So we know the total students is 10,000. And the students who are within 3 standard deviation is 9,970. If we subtract 9,970 from 10,000, what do we get? About 30, right? 30 includes lower end and upper end. But since those two are symmetrical, we can just divide that by 2 to find only one end. So 15. So the students here is about 15 and the other end is also 15. So how many scored above 800? About 15. Okay. Suppose that a group of students ask their teacher to grade on a curve. If the teacher gave a test to 200 students and the mean of the test was 71. So mean is 71 with a standard deviation of 7. The graph will look like this. Okay, so within 1 standard deviation, we know upper part is 71 mean plus 1 standard deviation, 7. So 71 plus 7. Lower part here is 71 minus 7, or 64. And 2 standard deviation, you can add double of 7, so add 14 or subtract 14 on the other side. That's 2 standard deviation, and you can continue to do that. So if your teacher is doing this method to give the students A, B, C, D, or F grade, figure out how many people per grade you can have. I think this is very interesting. Okay, how do we find that? 85 and above. So this is 85, right? It's 2.5% of the students. So out of 200 students, only 2.5% of students get grade A. So 200 times 2.5% or 200 times 0.025, you get 5 people. Do the same thing. Here, between 78 and 84, 78 and 84 here, only 13.5%, right? 13.5% of the students can be found 13.5% or 0.135 times 200 total, you get 27 students. Of course, it's symmetrical, so we get to know below 57 here is the same as above 85, and same for this number, right? And what's in the middle? That's one standard deviation number. So we know there are 68% of 200, or 200 times 0.68, you get 136. So 136 students get C. So small class like ours, it is really hard to get an A because only one or less than one student can get an A if we use the grade on a curve. Okay, that's why I'm not using that. All right, let's move to the percentiles. So when do we use percentiles a lot? Like standardized test scores on the ACT or SAT. Yeah, we can see the report as percentile. What does a percentile mean? A percentile shows a person's score relative to other scores. For example, if a student's score is at the 82nd percentile, that means that approximately 82% of those taking the test scored lower than the student, and approximately then 18% had a higher score. Okay. Then who has a higher score? Who has 82 percentile or 10 percentile? Yeah, 82 percentile is a higher number. Okay. So let me see. Here's one example. Okay, you are the 4th tallest person in the group of 20. So you are the 4th tallest. So this is you, and you have 3 more before you who are taller than you. What does that mean? 80% of people are shorter than you. So this means you are at the 80th percentile. How about this person? He's gonna be 90th percentile, which is higher than you, right? So if you think about the scores instead of that, let's suppose this guy has the highest score and this person has the lowest score. Okay, and this is you. You have 80 percentile in that score, which means there are 80% of people behind you and about 20% above you, right? So the higher number is better score. Like these people, they're about 50%, which is much lower than you, okay? So the higher percentile means you are on the higher score, okay? Okay, so here's another example. If your score is 62nd percentile, approximately 62% of those taking the test scored lower than you, and 38% had higher scores. For example, Asi was ranked 25th in a class of 250. What was his percentile rank? How would you find this? you can find 250 minus 20, right? Which is 225. So 225 students ranked below RC. And about 25 people above, 25 people are above RC. So how do we find the percentile rank then? We know there are 225 students ranked below RC. So we can do 225 divided by 250, the total number, right? Which is 90 percentile. That is 0.9, and you can multiply that by 100, which is the 90th percentile. And when you're checking the answer, always check whether it makes sense. RC was ranked 25th percentile. I mean, 25th, this is not the percentile. Ranked 25th means RC is top 25th out of 250. He did really, really well. So if your number, you think it's a 10% or something like that, 10th percentile? Oh my, that's too low for this, right? So it doesn't make sense. You can think that RC was ranked 25th, which means top 25th out of 250. So you need to look at who's below 25th. Below 25th, there are 225 students. So you can calculate percentile as what is below me or below RC. There are 225 people below RC. Divided by total number and multiply that by 100 to find the percentile. Okay? Another way to solve this problem is this. You can do 225 over 250 using the proportion. That is the same as what percent in 100. Why did I put 100 here? Because I put the whole number here. The whole is 200, part is 225. And then what is my part in percent? You can do cross multiplication. 225 times 100 is equal to 250 times x. 250 times x is equal to 225 times 100. So you can divide both by 250 and you get 90. So it is 90th percentile. So when you're calculating percentile, always look at how many are below. Okay? So how many are below divided by total number times 100 is the percentile. Okay, one more example. And then we're gonna finish this. In a class of 50, so there are 50 people, Kathy has a percentile rank of 60. A little bit above 50%, right? What is her class standing? How would you solve it? You get to know when you calculate 60% of 50, that gives you the number of people below Kathy's rank, right? So you can do 50 times 60% or 0.6, which will give you 30 students. That is the number of students below Kathy. So her standing, her rank, should be then 20 because there are 30 people out of 50 below her. Her standing should be 20. Okay? So Kathy's ranking should be 20th in her class. Okay? With this, I'm pretty sure you are able to solve all the problems on the homework. If you have any question while you are working on the homework or quiz, please let me know. Okay, have a good day, guys.